Hi everyone, in this video we are going to discuss renewable energy sources. So far in this module we've discussed a lot of different types of energy sources. So photovoltaic cells, electrochemical cells, we've even discussed fuel cells. But now what I want to do is just take one video to highlight 4 main renewable energy sources. Okay, so let's focus on that. Let's start off with a very simple definition of what a renewable energy source is. So renewable energy is simply energy from resources that can be replenished. Okay, that's a big part of it. They can be replenished on the human time scale. Okay, so within 100 years or so. So fossil fuels that take millions or hundreds of millions of years to create, that is not a human time scale. One human cannot live through that. So we're looking for certain resources. So common ones are going to be your sunlight, wind would be a good one, water would be a good one, and then we're also going to focus on geothermal. Okay, so these are the 4 I want you to focus on. A lot of notes in this video, so just hang on, all right? So number 1, first one is going to be solar thermal. Solar thermal. So this is kind of a unique version of solar energy using solar and heat, and so it kind of pushes it together. I really like this one. And so basically when you talk about solar thermal, what it is concentrating solar power. And a lot of times people actually just say CSP. So if you ever hear that, that's what it means. And this is really neat because what they do is they use mirrored arrays. So a bunch of mirrors, and then an array, just like we talked about with photovoltaic cells, so they create an array, but just of mirrors, but they use this to direct sunlight to heat water. Okay, and so what they can do is actually get this sunlight up to about 300 degrees Celsius, which is huge. And so picture a bunch of mirrors, you have sunlight coming in, and they're all grabbing the sunlight and then refocusing that, so reflecting that light out, and they're directing it at a pot of water, essentially. And they're just going to use all that incident radiation, they're just redirecting it, and they focus it in one section, and they can actually heat the water. Okay, and so now from that, with heated water, you can use the exact same type of process that is used in a conventional power plant. Once you have hot water, you convert it to steam. Steam goes to the turbine goes to the generator. You go from potential to kinetic to mechanical to electrical. So same typical process. So that's your solar thermal. After that, let's talk about wind. Wind is the one I have the most information for you, but that's just because I really want you to understand what wind actually is, and I don't ever get a chance to talk to you about this. So what is wind? Wind is when you have solar irradiance, or let's say solar radiation, and that's when it heats the gas molecules in the atmosphere. ATM, short for atmosphere, okay? So your sunlight, your incident radiation comes in, we know there's gaseous molecules here, the sunlight comes in, and it gives them a little bit of kinetic energy, so now they're moving around a little bit. So now, warm molecules have high kinetic energy. Okay, high kinetic energy. They're moving around a lot, high kinetic energy. This process is what generates what we refer to as wind. So molecules with high kinetic energy, they're moving, and when they all move together, we get wind, right? Neat. Okay, so now, wind turbines use very large blades. They are huge. I will never forget when I was driving from Michigan to Texas, moving here for the very first time. I was by myself in my car, and I looked over, and there was this huge wind turbine, one of them, one little piece, one blade I should say, just sitting there, and it was driving next to me, and it was the biggest thing I've ever seen. And I remember thinking, oh my gosh, life is very different in Texas. So it was just huge. They're huge. If you ever have an opportunity to see them, they're unbelievable how big they are in real person, okay? A lot of times people refer to those as pinwheels. Now, the last thing I want to say about this is that wind, which we know is kinetic energy, then spins the turbine. We know from previous modules that a turbine converts your kinetic energy to mechanical energy, right? And then our turbine is connected to a generator. And we know also that the generator then takes the mechanical energy and converts it to electrical energy. So same process that we're familiar with, but now we just kind of understand what wind actually is. But please, please, please do focus this. Please study this because it is important and it's nice to actually know what wind is. You experience that on a daily basis. All right, now let's talk about water. This one's fairly straightforward because what we're going to do is just look at hydroelectric pieces. So we're going to say hydroelectric. We're going to focus on dams for this section, okay? Use the potential energy of water. Potential energy of water in water. And then we use it to convert to kinetic energy in the turbine or before the turbine blade. So the kinetic energy then converts to mechanical energy at the turbine blades. And then after that, it goes to the generator, which we know converts the mechanical energy to the electrical energy. So hopefully you're starting to see this pattern. We use the same type of system. We just have to figure out how we can get that kinetic energy to spin the turbine. That's the big piece, okay? A lot of times we use hydroelectric dams. Just think the water is really heavy. It's really, really heavy. So if you have it coming to a high spot and then you have it drop down, there's a lot of potential energy stored in that water. So it drops down, and then as it drops, it's heavy. It starts to spin. You get movement. You build up kinetic energy. The turbine actually spins. As it's spinning, it goes from kinetic to mechanical, then in the generator it goes to electrical energy. So it's awesome, right? Very, very neat. So now the last one I wanted to focus on is what we call geothermal. And so for this one, I just want to focus on the heat from the core of our planet. Okay? So what we do is we drill into water reservoirs. All right? We drill into water reservoirs. And what happens is we are able to release the hot water or the hot steam that's deep into the core of our water reservoirs, okay? So it's a very, very important thing. So what we do is we can release this hot energy, release this heat. It's full of kinetic energy. And then what we do is we just harness that to spin a turbine. So it's the exact same concept. So we use the hot water, which we know is our kinetic energy, to spin a turbine. So geothermal is just getting that heat from the core. We drill into our hot water reservoirs, which are deep into the surface of our planet, grab that energy, throw it through a turbine, turbine to a generator, and it's the same process, kinetic to mechanical to electrical, every single time. Usually we do geothermal processes around volcanoes, so usually found around volcanoes. And the reason I'm highlighting this right here is just because I think it's interesting that Hawaii, one of our own states here, Hawaii actually gets about 25% of their energy by using geothermal processes. And that is because they're located near volcanoes. So they have a lot of that heat, that geothermal energy just sitting there right underneath their surface. So if they drill deep enough down, they're actually able to get that energy. Okay, now here is my question. Out of these four processes, so you have solar thermal, you have wind, you have water, and you have geothermal. Of these four, which one do you personally, and this is your own opinion, which one do you think should we focus on and try to use this energy to actually power our entire planet? Go. All right, did you get an answer? Hopefully you did, because it's just an opinion piece, but the correct answer is all of them. We have to use all of these in order to power our planet. Not one of them is going to be enough. It's the conjunction, it's the combination of every single one of these. I personally would like to throw fuel cells in there and photovoltaic cells, and if I can, nuclear energy. I want to throw that in there because that is just going to be our best way of actually powering our planet without contributing to global warming. Take care of yourself, have a fantastic week, and drink water.